Hey guys. All right, so today is virtual day 9, March 25th. I am showing you right now our class outline, so I'm just going to go back up just so we can be clear on what is due and when. We worked on our midterm exam. You took 4 virtual days to do that. It should have been turned in to Google Classroom on Friday, March the 20th by 3 p.m., okay? If it wasn't, please email me so we can chat about your next steps. This needs to be done. This is a big deal. All right, so looking at Unit 5, you can kind of see what's going on here. As of right now, we're still planning on coming back. That's my hope. On the 30th, we'll see how that goes. Right now it is March 17th, so forgive me if that's not accurate information. So right here, we've got our day. I'm giving you 2 days for what we would usually do in one because of the chaos of everything. I'm sure you've got other things going on at home to deal with. If you'll just click on the link for the video, if you haven't yet, that will be the video for the first day. You're going to copy down these notes, and this geometry terminology is a big deal. It would really benefit you to write them all down by hand. There's a key right here. You don't even have to look up the definitions. You can just copy that down. That would be really helpful. You have your practice, and I have the key and your homework and the key for you. That is just for you. I'm not going to be taking that up. But if you're struggling with this, if you don't remember this, that's what you need to be doing and checking yourself with the key. The Delta Math over here is going to be your grade for virtual day 7 and 8. So today we're starting here, and this video will be a link there once it's complete. You will fill in these notes with what we're doing today and work on the practice with the key and the homework, as well as this Delta Math will be the grade for today. So if you can just look through the outline and figure out what you need to do, that is going to be your best bet right now. So now I'm going to, what you should have done at this point, you should have completed your midterm exam, Unit 5 Day 1 notes, Unit 5 vocab, and Unit 5 Day 1 Delta Math. This was from 323. So please make sure that you've got everything done and you're caught up as much as possible. I'm doing my best to stretch this out for you guys so you don't have too much to do on one given day. But please know that you have got to stay on top of this. It's going to be really hard to catch you up when we get back if you've not been on top of everything you're supposed to be doing. So we're going to start with proofs today. Day 2, parallel lines, angles, and some triangle proofs. If you remember triangles from Math 2, side, 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 angle, and angle, angle, side. So triangle congruency theorems. We have side, 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 angle, side, angle, and angle, angle, side. There are no curse words in math. So that would be side, side, angle. If you rearrange that, that is not one that would prove these guys congruent, okay? So you have to prove triangles congruent. It has to be one of those 4 congruency theorems. There's also HL, which is hypotenuse leg. That only works for right triangles. Those are the only triangles that have a hypotenuse. So if you have a hypotenuse and you have a leg, then those 2 right triangles are congruent. So now we're just going to start. I'm just going to jump in with these proofs. You are always going to start with what you're given and work towards. Bells are still on. Work towards what you have to prove. So we're given this picture, and I always say to mark it up. So when it says that angle YLF, so the order of these letters matter. YLF, you're going to start at Y, go to L, and then go to F. So the angle that it's talking about is the angle in between here, which is this angle. It says angle YLF is congruent to angle FRY. So that would be this angle. Always mark up what you're given and mark it up as you go. That helps you to see these things so you know when you're done proving. It also says the angle RFY. So RFY is this angle. So the same amount of hash marks means they're congruent. This one has 1 hash mark. This one has 2, so the next one that it says congruent to is going to also have 2. LFY is this guy, so it's going to have 2 as well. So that means that these 2 angles are congruent and these 2 angles are congruent to one another. It wants us to prove that triangle FRY, so that's this triangle here, is congruent to triangle FLY, which is this triangle here. So this is called a 2-column proof, and one column is going to have your statement, what you're assuming or what you are able to prove, and then your reason how you are able to prove that. Those are very important. We're going to start with given statements and work our way towards writing them completely on our own. You always start with what you're given. So angle YLF is congruent to angle FRY. How do we know that? Because it is given to us. They gave it to us here. You have to be given some information in order to prove things congruent. Angle RFY to angle LFY, again, is given to us. Then it says that side FY is congruent to side FY. So that is this side is congruent to itself. If you look back at those definitions you were supposed to copy down on day 1, the reflexive property means that something is congruent to itself. Reflexive property of symmetry or of congruence. If some FY is congruent to itself, it is the same as itself. I am me. We're the same thing. So that's where the reflexive property, it is congruent to itself. So now we've got angle, angle, side on this triangle and angle, angle, side on this triangle. So we know that triangle FRY and triangle FLY are congruent by angle, angle, side. So remember, you have to go in order here, angle, angle, side, angle, angle, side. There's not a side in between. If it was the side in between, then it would be angle, side, angle. So do be careful with which one you use. This is not the same thing as angle, side, angle. The next one. It says segment LT is congruent to TR. So LT and TR are congruent. It says angle ILT is congruent to angle ETR. So ILT is this angle and ETR is this angle. Those might look perpendicular, but never assume anything unless it is given to you. So never assume. It must be given, or you must be able to prove it. And then it says that IT is parallel to ER. So this IT is parallel to ER. So now LT and TR, that's given to us. That's how we know that's true. Angle ILT and angle ETR, again, is given. And most of the time I will write all of my givens as one statement and have, instead of having 3 different statements here, like this one does. So whenever I'm doing it on my own, I will probably write this as a 3-statement piece and combine these 3 into one statement. Then it says that angle LTI, so LTI, that is this angle here, is congruent to angle ERT, so that is this angle. How do we know that those are congruent? Well, think about this. You have this line and this line, those guys are parallel. Then you can treat this as your transversal. If that is your transversal, and these are parallel, then these 2 angles are corresponding angles. They're in the same relative position at the intersection. So these are corresponding angles. And that makes triangle LIT congruent to triangle TER by angle, side, angle, angle, side. The next one, C is the midpoint of BD. AB is perpendicular to BD, so I'm going to mark that as a perpendicular. And BD is perpendicular to DE. BD, CE, and another perpendicular. So C is the midpoint. We want to prove these 2 triangles congruent. C is the midpoint, that's given. And the fact that those are perpendicular is also given. BC is congruent to CD. Well, if C is the midpoint, then that means it breaks this into two congruent pieces. So BC has to be congruent to DC by the definition of a midpoint. Angle BCA is congruent to angle ECD. That's this angle and this angle. Those are congruent because anytime you have two intersecting lines that create vertical angles, and vertical angles are always congruent. It says angle ABC and angle EDC are right angles. They are right angles because those lines are perpendicular. So this is by definition of perpendicular. And angle ABC is congruent to angle EBC. That is because all right angles are congruent. That might seem a little redundant, and sometimes it is, but do know that all right angles are congruent to one another because all of their measurements are 90 degrees. And now, because we know that this is congruent to this one, these sides are congruent, and these angles are congruent, we know that these triangles are congruent by angle, side, angle. Angle, side, angle, angle, side, angle. We have quite a few of these proofs to get through. I'm not going to do all of them with you. I'm going to leave some of them for you to get online. On the key to the notes, I'm going to do, so these are the triangle ones. I'm going to do one more triangle. I'm going to do a couple more triangles. And then we're going to move on to some lines and angles. Starting with our triangle here. Given that BA is congruent to EB, so BA and EB are congruent, and C is the midpoint of BE and AB, so this bisects not only BE but also AB. Proof. So BA is congruent to EB, that's given. C is the midpoint, that is given. BC is congruent to EC, well, if C is the midpoint, then that means it bisects those into two congruent pieces. So this is by definition of midpoint. AC is congruent to DC, same situation. If C is the midpoint, it bisects these into two congruent pieces. So the reason for 4 is also definition of midpoint. And now we know that these triangles are congruent because of side, 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 side. The next one, number 10, BC is congruent to DA, and AC bisects BCD. When it says bisects, that means cut into two congruent pieces. So BC is congruent to DA, and AC bisects that angle BCD. That means it splits it into two congruent angles. So this one is given. And number 2 is also given. Number 3, those are congruent, and that is the definition of bisects or bisector. It says AC is congruent to AC. That is the reflexive property. But then it says that triangle ABC is congruent to triangle CDA. So if we look at what we've got here, we've got side, angle, side for triangle ABC. And triangle CDA, we have angle, side, side, which remember there are no curse words in that. So if we knew a little bit more about this, like if we knew this was a parallelogram, or if we knew that these set of sides were congruent, If we knew just about anything else about this quadrilateral, then we would be able to prove this congruent. But because this triangle, the triangle ABC, has side angle side, and this triangle, triangle CDA, has side side angle, we can't prove these congruent. These do not have the same situation going on both triangles. So I don't think that we can prove this congruent. Without making assumptions about this, we cannot prove that they are congruent. Now we're going to start with just writing them straight up from what is given. So you're always going to start with what's given. So I'm going to have my statements column, and then my reasons. It says that angle ADB and angle CDB are right angles, which is already noted. And it says that angle A is congruent to angle C, which is also noted. We want to prove these two triangles congruent to one another. So I'm going to start with my given. I usually combine my given into one statement, but for the sake of kind of clarity on what's going on, what we've done before, I'm going to go ahead and split it up. So it says that angle ADB and angle CDB are right angles, and we know that because it is given to us. And then number 2, angle A is congruent to angle C. Again, that is given to us. We can say, because those are both right angles, and this might seem redundant, this would probably be a step that most of you would skip, but don't skip this step, that angle ADB is congruent to angle CDB, and we know that because all right angles are congruent. Then what else can we say just based on this picture? Nothing else is really given to us except for they share this side. Anytime they share a side, you're pretty much going to use that. So we can say that BD is congruent to BD. And we know that because of the reflexive property of congruence. Now we can prove these triangles are congruent by angle, angle, side, angle, angle, side. So phi, triangle ADB. And you pretty much always want to write this the way that it has it when it says to prove it. Is congruent to triangle CDB. And again, angle, angle, side, angle, angle, side. And now we're going to look at a few parallel lines and transversals. And again, I'm not going to do everything that I can, all of these here. I'm going to let you look at some of them online on the key, but do look at a few of these with me. This time we're looking at parallel lines and their angle relationships. That would be alternate exterior angle, alternate interior angle, vertical angles, corresponding angles, linear pair, and same side or consecutive interior angles. So it says that AB is parallel, and that kind of smudged a little bit, but that's just the symbol for parallel. It's parallel to, A is parallel to B, and C is parallel to D. So just like with the notches, same number of arrows means that they are parallel to one another. We want to prove that angle 1 is congruent to angle 13. So what I want to do is when I'm writing these on my own, I'm going to start with one of the angles and relate it to an angle that can be then related to the last angle that I want. Typically 3 or 4 steps. So we know that these guys are parallel because that is given to us. Angle 1 is congruent to angle 12. Well, if we look at these two being my parallel and this being my transversal, angles 1 and 12, we know that they're congruent because they are alternate exterior angles. Turn your paper around if you need to see that. If cover up pieces that may help be difficult for you to see. But these two angles are alternate and they're outside of the parallel lines that we're looking at here. So these two are alternate exterior. Then it says that angle 12 is congruent to angle 13. So 12 and 13 here. Now I'm just going to cover up this side. These two, if these A and B are my parallel lines, are alternate interior angles. So I know that angle 12 is congruent to angle 13 because they are alternate interior angles. And then angle 1 is congruent to angle 13. If you look back at those definitions that you were supposed to copy down on Monday, this is true about the transitive property of congruence. And that just says if I have blue eyes and you have blue eyes and then your mom has blue eyes, that me and your mom have the same color eyes, just by that transitive property, it goes from one thing to another. It just means that we're all the same here. So the transitive property says that those two are congruent. A is parallel to B. So again, that's the only thing we're given. Now we need to prove that the measure of angle 9 plus the measure of angle 14 is 180. Remember, when the sum of two angles is 180, that means that they're supplementary. That's what we're trying to prove. So angle 9 is here and angle 14 is there. We're trying to prove them supplementary. A is parallel to B. That is given to us. 9 and 11, their sum is 180 because they are a linear pair. Linear pair means there are two of them together create a line. 11 is congruent or equal to 14. So this means the measure of angle. Just write that here. Measure of angle 14 is what that means. So we're just talking measurements here in equations. Measure of angle 11 is equal to measure of angle 14. That's because they are alternate interior angles. We've got 11 and 14 are congruent. And then it says the measure of angle 9 plus the measure of angle 14 is 180. If we started with this equation and we know that these two things are equal, then what we can use is substitution. We can plug in 14 where 11 was and know because they're equal that it doesn't change our equation. So this reason would be substitution. Sorry, spelled that wrong at first. The next one, we are given that G and H are parallel and that angle 1 is congruent to angle 2. We are asked to prove P and R parallel. So our first reason is always given. Angle 1 is congruent to angle 3, so I'm going to ignore this bottom piece here. If this is our parallel lines and P is our transversal, 1 and 3 are congruent because they are corresponding angles. Then it says that angle 2 is congruent to angle 3. Well, if we cover up everything else, then P and R are our perpendicular angles, and H is our parallel lines, and H is our transversal. So 3 and 2 are congruent because they are corresponding angles again. Oh. Whoops, look what I did. So what I did there was assume that P and R are parallel, but that's what I'm trying to prove. So this is a really common mistake that a lot of you are probably going to make. So I'm actually kind of glad I made that mistake. You cannot say that those are congruent because they are corresponding angles because we do not know that P and R are parallel. That's what we're trying to prove. So that's a pretty common mistake. But what we do know is that those two are congruent by the transitive property. We started off with 1 and 2 being congruent. And then, why that was not working very well. We started off with 1 and 2 being congruent. And then we said, well, 2 and 3 are 1 and 3 are also congruent. So that means that 2 and 3 are congruent. by the transitive property. That's not dry yet. Transitive property of congruence. So that is going to go right there. So if 1 is congruent to 2 and 1 is also congruent to 3, then 3 and 2 are also congruent. Now we know, because 3 and 2 are congruent, that these two lines are parallel. We know that because their corresponding angles are congruent. If the lines were not parallel, then their corresponding angles would not be congruent. So because their corresponding angles are congruent. If you have questions about that one, feel free to shoot me an email. I'm happy to help you. Whiteout is just not working very well, and the other one is really dried up. So again, whenever you are trying to prove something, you cannot use that in your proof. And if we had used corresponding there, then we would have been using, they're corresponding because these two are parallel. We would have been using that in our proof. So we can't do that when that's what we're trying to do. All right, now we're going to do a couple, writing them straight on, and then I'm going to get you to copy down the last 2 pages on your own. It's front and back. It's not super hard, but it is good to write them down and work through them on your own so that you can see why things work. If you don't want to do that, whatever suits you is fine. Just if you get to your practice homework in Delta Math and you're having trouble, please make sure you go back and look at those last 2 pages. So here we are given that G is parallel to H. That's kind of hard to read, so be careful there. G is parallel to H, and angle 1 is congruent to angle 5. So we're given this one and this one. We're asked to prove that angle 5 is congruent to angle 3. So we can tell, because G is parallel to H, I'm going to start with what I'm given, and then I want to start with one of my angles and relate it to a different angle that I can then relate to my last angle. So my first statement is G is parallel to H, and angle 1 is congruent to angle 5. My reason there is given. So because I want to prove 5 and 3, I'm going to start with angle 1, and I'm going to relate it to angle 3 first. I can see a clear relation there, 1 and 3, because G and H are parallel. This would be our transversal. I'm just going to call it T. That means that 1 and 3 would be congruent there because they are corresponding angles. So number 2, angle 1 is congruent to angle 3 because they are corresponding. Remember, corresponding means that they are in the same relative position at the intersection. This one's at the top left, this one's at the top left. So now that I've related angle 1 to 3, and angle 1 has already been related to angle 5, then I could use the transitive property to say, well, if 1 is congruent to 5 and 1 is congruent to 3, then 5 and 3 must also be congruent. So angle 5 is congruent to angle 3 by the transitive property. You can also have said substitution there, because 1 and 3 are congruent. You can just take out that 1 and sub that 3 in, and that would have worked as well. All right. Number 5, given G and H are parallel, and angle 6 and angle 3 are supplementary. So now we're saying they're supplementary. We want to prove that 6 is congruent to 2. So I'm always going to start with what I'm given. So given G is parallel to H, and angle 6 and angle 3 are supplementary. Now, 6 and 3 have already been related, and I want to prove 6 and 2. So I'm going to try to relate 2 and 3 so that I can then use some substitution. So 2 and 3, if you look at them here, they are same side or consecutive interior angles. So we can say that angle 2 and angle 3 are supplementary. angle 2, and angle 3 are supplementary. And we know that because they are consecutive interior angles. So number 3, I'm going to set up 2 different equations here so that I can then use substitution. The measure of angle 6 plus the measure of angle 3, that equals 180. That's by definition of supplementary. And I can say the measure of angle 2 plus the measure of angle 3 equals 180. So again, this is by the definition of supplementary. So then I can say that the measure of angle 6 and the measure of angle 2 are congruent to each other, because if I substitute this in, if I add the same thing to the measure of angle 3, then I get 180, right? So these two are constants. If I subtract and solve, then I get the measure of angle 2 equals 180 minus the measure of angle 3, and the same for the measure of angle 6. I might even write that down just so you can kind of see what's going on here. This equals 180 minus the measure of angle 3, and the measure of angle 2 is going to do the same thing if you just rearrange your equation. So this is the commutative property, I'm going to say. Of addition, subtraction. And then number 5, I can say that these two things are equal. So the measure of angle 6 equals the measure of angle 2, which then means that angle 6 is congruent to angle 2, and this is by substitution. This step wasn't completely necessary. It was more just to show you what is going on in my thought process behind substitution. And then the last one I'm going to do with you, given CD is parallel to AB, and angle 2 is congruent to angle 1, prove that angle 2 is congruent to angle 3. So since these guys are parallel, it's good sometimes to extend them so you can get a better picture of what's going on. I'm going to start with my my given. So CD is parallel to AB, and angle 2 is congruent to angle 1. So since 2 and 1 are given to me, I need to relate 2 to 3. So I'm going to try to relate angle 1 to angle 3 so that I can then use some substitution. If these are parallel lines and this is our transversal, then angles 1 and 3 are congruent because they are alternate interior angles. So angle 1 is congruent to angle 3 by alternate interior angles. And then we can say that angle 2 must be congruent to angle 3, and you can say either the transitive property or substitution. Either one works here. And that is that. Please look online at the key for the last. There are 5 more that are there for you as examples. I feel like this is probably enough to get you going. But if you have any more questions or have any issues, then do look at the key on the outline for today's notes for the last 2 pages for some extra examples. Copy those down and get what you need. Make sure that you're working on the practice, the homework, and the Delta Math is the grade. So again, check the Delta Math assignment online for the deadline. The late date, which is only 90%, so it doesn't really take much off, 90% credit, is a week after the due date. So do check that due date. These are going to be daily homework grades. I haven't decided exactly what I'm going to do about the unit practice yet. I may not do that since it's a new quarter for this stuff, and we'll see what happens. So if you guys have any feedback, do let me know. And I hope you guys have a great day. Bye.